Hello, everyone. Welcome to the Construction Show. I am your host, Jared Downey, and we are kicking off. Gowdy hates when I do this, but this is the first episode we are filming at WEFTEC in 2024. I'm not sure if it's the first one you're going to be seeing released, but it's early in the morning, and we're kicking off with Blacoh Industries. Chris Richey, he is the Engineering and Product Development Director at Blacoh. Chris, welcome to the show.
Hi, good morning. Thank you. Nice to be here.
Are people already filing into the event?
Yeah, it opened about 30 minutes ago, and it's starting to pick up slowly. I'm sure there's plenty of people waiting to get their badges still in line, but it is filling up.
I have to say the water industry is probably, out of all the heavy industries, it's one of those ones. I thought I had some pretty basic understanding. Then I started prepping for all the episodes we're doing here, and I just got more and more confused. So forgive some really probably beyond even layman questions. There's probably going to be some confusing questions. I've worked with pumps as a kid. I just never got into the whole sort of system. So
Right.
I really will be talking about someone who's being introduced. So just bird's eye view, who is Blacoh?
Mm-hmm. Blacoh is a pulsation dampening company. We've been around since the 1970s, and we've been working with positive displacement pumps primarily, and even getting into centrifugal pumps in the last 10 years or so. But for the most part, it's a company that makes devices that are designed to protect pumps and systems from the pulsation that comes from positive displacement pumps. It's an unavoidable part of a positive displacement pump, and they're necessary in a lot of different applications. So Blacoh makes things to make those pumps easier to work with and more reliable.
So this is an example of something I just didn't know. I didn't realize. So these pumps, if they're left without any sort of system in place, they actually will pump the fluid out in basically just spurts as the pump moves, right? Is that because
That's correct.
Is that because it's a single diaphragm then? Because just one thing basically pushing the pressure on?
Well, there's for example, in the air-operated diaphragm pumps, there's actually two. It moves back and forth. But in either case, when it shifts one way or the other, you're getting a surge of fluid in one direction coming out the pump, and you're getting a surge of fluid after that coming out at the pump again. So it's just a natural part of the way the pump operates that you're going to get pulsing flow. And there's lots of pumps that are like that. An air-operated diaphragm pump is one example, but there's also metering pumps, there's reciprocating piston pumps, there's a wide variety of positive displacement pumps that all have this same natural component of how they operate. And some are better and some are worse, but it exists in all of them. It's really unavoidable.
So what is, just before, I want to get into you got some really good graphics and things. They're actually on your website. So we're going to put a link to that so people can reference it. But before, what is just sort of your day-to-day role with the company?
Well, my role as the engineering and product development director is to work with the existing products that we already have and work with the sales team to be able to adapt those or specify those into the right applications. And then also to work with our internal engineers on developing new products that are fitting the needs of our customers. So as I mentioned before, that Blacoh has been around since the 70s, but positive displacement pumps have been around for thousands of years, and they have a lot of use in industry, not only in water, but in lots of other areas as well. And they're going to be around for a long time because they are so useful. But the components that go along with a positive displacement pump, or even the systems, need to continually develop to make them more reliable. And if you think about, as in any industry, as things go along over time, you find new problems, right? You come up with a new solution to a problem, but then you realize, well, that also causes something else that we hadn't had to deal with before. And that's what we deal with on the product development side is, what are the problems now? What are the problems that customers are seeing? What is their pain? And how do we develop something to be able to address that directly? So on the product development side, that's the part that we're looking at there, is how do we address the new problems that customers are seeing, while on the engineering side, still working with customers on the problems that they've been dealing with for thousands of years.
Let's talk about our Heavy Industry World Tour, brought to you by Sabinow Equipment. Find, market, and sell surplus and used equipment. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Are you facing the challenges of CO2 shortages in your construction projects? Secure your CO2 supply today with Tomco Systems, the pioneers in CO2 equipment solutions. With over 45 years of experience, Tomco transforms challenges into solutions, offering a comprehensive range of CO2 products for water treatment, storage, and transportation. Tomco Systems' patented CO2-based water treatment and wastewater treatment solutions have gained global recognition for their efficient and precise pH control systems. Whether you need pH reduction for municipal process treatment or industrial wastewater, their line of carbonic acid storage and feed products will provide you with 95% or greater efficiency in reaching your target pH. Don't let shortages slow you down. Visit tomcosystems.com to learn more. When it comes to balancing the growing demand on your grid with the growing need for more responsible, sustainable energy production and generation, you need the right partner. A partner who delivers long-standing grid expertise from a team dedicated to your unique needs, and one who supports that team with innovations designed for the future needs of your grid, while being rooted in proven electrification excellence. ABB is that partner, offering solutions that meet technical requirements, regulatory compliance, and recognize the need for sustainability in your business operations, as well as in the lives of the surrounding communities. Solutions that expertly blend physical services and solutions with next-level digitization. Solutions that enable safer, smarter, more sustainable operations. ABB is the name to trust to help modernize your grid. Learn more at abb.com/CA.
So I want to back way up. Back in, I don't know, let's say the 50s, when they were doing, when they had these pumps, were they just timing? They just sort of accept that pulsation without the dampeners?
Yeah, it was kind of just, like you said, accepted is a good word for it, that there were very few devices to do anything about it. There's ways of adjusting piping setups and adding more pistons into a plunger pump, for example, to try to smooth out that flow. But you still get to a point where you have a pulsing flow at some point. And with the air-operated diaphragm pumps, because they're used for some pretty difficult applications of pumping things like wastewater that might have solids in it, paints, very viscous fluids. And when those pumps started coming out, because of the way that they work, and there really is only an opportunity to do two pistons or two diaphragms in one pump, you had a situation where pulsing flow was exaggerated. So it's kind of impractical to put a multiple diaphragms in line. It can be done, but it just becomes a little bit cumbersome. So that's when pulsation dampening really gathered some steam. This is a great pump. It's a really nice technology. It functions in a lot of good areas, but it's also really hard on the systems. So pulsation dampening became much more valuable.
Before we get into, I just want to ask one more question about the pumps themselves. Are the reason they're such good pumps is because they're robust, like they can put stuff like paint through them, or what makes them such a sort of a mainstay?
Yeah, I think you hit on it, that they're very robust, and they're designed for certain applications that other pumps, centrifugal pumps, for example, would have a very difficult time handling. There are centrifugal pumps that can deal with solids and wastewater. Of course, those things exist. But when you start getting into really viscous fluids or having to pass solids through them, large solids, it becomes very difficult to move that with a centrifugal pump just because of the way that it works and the clearances that are inside of it. With a diaphragm pump or a positive displacement pump, you can actually push that fluid, even if it's very, very thick, or even if it has solids in it, large solids, effectively. So there's a lot of value in a positive displacement pump in general. And then, of course, as we said, the air-operated diaphragm pump specifically. And then even looking at things like metering pumps, where you have to inject a very precise amount of fluid into a system. A centrifugal pump has a difficult time with that. But with a metering pump where you're moving a piston, you can say, I'm going to inject exactly this much, right? I'm going to move this piston this far, and that fluid is going to go into that system. So it's as I mentioned before, it's a situation where the applications call for that kind of pump. The drawback to it is that to use that kind of pump, you naturally end up with this pulsing pressure and pulsing flow that can damage the system.
Okay, let's get into this diagram on your website is really nice. Again, we're going to have a link to it. For anybody watching, if you're watching on YouTube, let's say, in the description below, there'll be a link. I'll get the team to put it right at the top there. So you'll be able to go in and actually walk through, but we'll do a visual as well. We've got this metering pump system overview, and it's a really nice graphic on your website. You can actually click onto it and bring up a description of the different parts.
Right.
I think you have it in front of you as well. Can we just walk through this, and then we'll bring it up on the screen as well?
Yeah, sure. So I mentioned before when you were asking about what does Blacoh do, that primarily it was built on pulsation dampening, and that's true. But Blacoh also offers a wide variety of other components that go into a metering pump system. So if you're looking at the diagram, you'll see that there are the pulsation dampener at the discharge and also the inlet stabilizer on the inlet side. But there's a bunch of other components in there that all go into making a metering pump system work. And Blacoh offers all of these things. So if we kind of walk through from the very beginning, the fluid's coming out of the tank and going towards the pump, of course, but because we have pulsing flow at that pump, and this is a metering pump, it's a piston pump essentially, because we have pulsing flow coming out of the pump, that means that we also have pulsing flow coming into the pump, right? Because the flow into and out of the pump has to be the same. So the inlet stabilizer is essentially a pulsation dampener that's specifically charged and designed to work on the inlet side. Lower pressure, less variation in pressure, but still a pulsing flow and a pulsing pressure. Blacoh provides these in a wide variety of sizes and materials and can be used in any application where you have a positive displacement pump drawing fluid in.
Sorry, can I just jump in? Sorry, Chris.
Sure.
Can I just jump in for a sec? Can you just give me the base? Like, how does this actually work? There's basically an air pressure that, what does it do? Suppress the pressure when it's high and then eases off, like it automatically does it, or what is actually happening?
Okay, and you're pretty close. So what a pulsation dampener does, whether it's on the inlet or the discharge, is it's taking and giving energy to the system. So the pump is where the energy goes in, right? That's where you have your motor that's actually driving the fluid to increase pressure. But you also have the piping that the fluid is passing through that's being subjected to changes in pressure. Well, that pulsation dampener typically has a bladder inside of it that's charged with the air, nitrogen, or just regular shop air that is at lower pressure than the fluid, so that it compresses a little bit when the system is opened and it's exposed to that pressure. And then as the pressure changes inside of that line, the bladder either compresses a little bit when the pressure is higher or expands a little bit when the pressure is lower to equalize that pressure. So as it's compressing, it's taking energy from the system. As it's expanding, it's giving energy to the system. But the net effect is that because you're allowing it some of that flexibility inside of the system, you reduce the variation in pressure in the piping. So that's what smooths out the flow and makes it a lot easier for the pumps to operate, because instead of seeing a change of pressure of maybe, let's say, 10 psi as the pump goes from a suction stroke to a discharge stroke, you're maybe seeing a change of only a couple of psi, because that dampener is softening that effect and taking and giving energy as needed.
As heavy machinery specialists for construction, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their construction customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your job site. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com. Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymond's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com. Join us in the depths of the mining world, where global leaders and industry giants converge to shape the future of mining. From groundbreaking technologies, advanced machinery, revolutionary safety measures, to sustainable initiatives. This is the voice of mining. This is Mining Now. Showcase your company to millions worldwide. Book your episode now. Visit crownsman.com.
What is it? Again, I'll let you move on to the next thing. But what is the difference between a good stabilizer and a poorly manufactured one? I know Blacoh's sort of this leader in the space. So what actually defines it as the higher quality product?
Well, if you're talking about performance of the product itself, it really comes down to the way that the internals react to pressure. And Blacoh uses a diaphragm we can do it in different materials, of course, but it's made to be flexible and it's made to contain pressure, of course, but also be able to flex and as I mentioned, take and give energy when needed. And lower quality dampeners would in some cases use materials that are very durable but a little bit less flexible and wouldn't respond quite as quickly. And because of that, you would end up getting more pressure differential between your inlet stroke and your outlet stroke because it can't react quite as quickly. Another thing to look at is just the quality of the construction of the shell. When you get down to it, it's a pressure vessel, right? Like anything else that you would put pressure into, you need to be sure that that vessel is safe. As you add fluid pressure to it, as you add air pressure to it, you want to be sure you have a reasonable safety factor over the pressure that it's going to see. You really don't want to find out that that vessel isn't strong enough when it's under pressure. So Blacoh tests their vessels and tests their diaphragms to 4 times the pressure that they're going to see. And this gives us a lot of confidence that when we put those things out into the field, that even if the system goes well beyond what we thought it was going to be, the dampener will still stay intact and contain that fluid.
That's it's funny your answer about that the flexibility of the diaphragm. That reminded me. I had an interview about steel, and it was a very similar answer. Like you could look at it, it looks the same, the grade's the same, but there's this material quality that makes all the difference. And like consistency when it goes into a machine shop, how you can actually work, how it bends, all that sort of stuff. It was very similar to that. Like you could look at this and go, oh, it looks exactly the same, and it is not the same thing.
Right.
Okay, I jumped in. What is the next part you wanted to cover?
Oh, the calibration column. So this is another component that Blacoh provides, and this is used to be able to set the stroke rate of the metering pump. So as I mentioned before, when we're using a metering pump, we're normally injecting a specific quantity of some liquid, right? A lot of times it's used for treating water or to cause a chemical reaction to happen down the line, and you need to inject the right amount. So in order to make that work correctly, you have a flow rate in the line that you're pumping into, and then you also have a flow rate of the fluid that you're pumping into it with the metering pump. So you need to balance those two things. The calibration column is used to set the flow rate of the metering pump so that it matches the addition rate that you want to have into the main line. And these are typically, I shouldn't say typically, these are always unpressurized devices, but they are required to be able to set up a metering pump skid correctly. Because if you're using it to meter and add something into the line, you need to know how much you're adding and how quickly.
So this goes in, this goes between, I'm looking at this chart here. I'm sorry. I won't spend too much time on it because I realize there's people that have a better understanding, so I won't bog down the whole interview because of it. This is helping manage the inlet and outlet. I'm sorry. I don't quite understand where this plays into the system. I'm seeing it here.
No, it's okay. Yeah, it's a great question. So if you look at the line coming in from the bottom from the tank, that's the fluid that you're adding, right? At the top, you have a valve, and then you have a line that's coming off the pressure relief valve, which I'll talk about in a few minutes. But it goes back to the tank, right? So the way that this works is you would open the valve at the bottom and the valve at the top. You would draw a certain amount of liquid into the calibration column, and then you would close the valve at the top, and you would pump that fluid out, right? So you would see over a certain amount of time how quickly is that pump drawing the fluid out of that calibration column. So that tells you the flow rate of the pump specifically, right? But under normal operating conditions, both of those valves are closed. Once we've set the flow rate of the pump, it stays like that until we need to change it. So that calibration column is only used to set the initial setup of the metering pump.
Right. So that's what you're saying. If there's a specific feed that needs to go into a tank, then this basically manages it to exact then.
That's right. The metering pumps are typically running on a variable frequency drive, so you can adjust the speed, and as you adjust the speed, you're adjusting the flow rate. So as you're drawing down the liquid in the calibration column, you can adjust the speed to get to the flow rate that you need, and then once you have that, you set it and you don't touch it again until you need to change that injection rate.
Okay, let's go on to the next section.
Sure. So we pass through the pump, which is the component doing all the work for us. And then we move into the pulsation dampener on the discharge side of the pump. This is where we see the highest pressure differential because this is right after the pump. We're seeing the pump is adding energy to the fluid, and we want to dampen this as much as possible because we're trying to get to a very even average pressure is a good way of saying it. So let's say that your normal pressure or your average pressure should be about 20 psi. Well, if you have no dampener in place, you might swing between 5 psi and 35 psi. If you have a dampener in place, you can probably control that down to somewhere around 18 to 22. So the dampener makes the pressure coming out of the pump a lot smoother, which makes it easier on the pump. It's not having to accelerate that fluid every time to overcome the low pressure that came from the pump being on an inlet stroke. And it also eases the load on all the components downstream of that pulsation dampener, because instead of getting these shocks of plus or minus 15 psi, it's only getting a shock of plus or minus 2 psi. And of course, this gets to be more and more important as you get into higher pressures, right? If you think about, basically, we talk about pulsation dampening as a percentage. So how much residual pulsation do I have? Well, percentage is relative to the average pressure. So if the pressure is 20 psi and I have a 5% residual, that's a whole lot less pressure than if I have 1,000 psi and I have 5% residual, right? So as you get into larger pressures, you start to see that the pulsation dampening becomes even more important.
Oh, I see. Okay, so then we're moving into, so we're at the outlet pulsation dampener, right? And now we move into, where's the next section we move into?
After we go past the pulsation dampener, we're going to go up to the pressure relief valve. So this is used to protect the system, right? Most systems, well, I shouldn't say most, all systems are rated to a certain pressure. How much can the fittings handle? How much can the pulsation dampeners handle? How much can the piping handle, right? All these things are rated to a certain pressure and temperature. So if you were to exceed that, you could damage a sensitive component and cause a safety risk of something breaking, right? And releasing liquid to the atmosphere, which is a big problem. So the pressure relief valve is used and set at a point that if the system can handle the pressure up until a certain level. So you set that pressure relief valve at a pressure just slightly higher than what you think is going to be the max. So if something goes wrong, someone closes a valve downstream, the pump plugs or something like that, and you get a really big spike of pressure, then the pressure relief valve opens and relieves that pressure back to the suction source in this case. So you can see on the bottom of that pressure relief valve, we're allowing that liquid to go back into the tank.
Oh, I see. Right. Okay. That's why it's that.
That's right.
That's another feed into the tank.
Calibration column. Yeah. You can use that as kind of a relief because the tank is back at inlet pressure, right? So if there's a problem, the pressure relief valve will open and it will allow that extra fluid to go back to the tank as opposed to overpressurizing the components in front of it.
I feel like after this interview, I'm going to be talking to someone and I'm going to act like I actually know something about all this because I'm getting like a step-by-step. Okay, next section is, well, now we're going up into the degassing and the diaphragm seals. Is that right?
That's correct. So when we go through the pressure relief valve, if everything is good, we're still within the pressures that the system can handle. The fluid just passes right through. And then we're going now, it's going to split, right? So we have two directions. We're going to go left first. And we're looking at the degassing valve. The degassing valve is used to keep the pump primed as well as to remove any air that might accumulate in the system. So as you're drawing off of the tank, right, you have a certain level in the tank and if everything is going as it should, the tank level is sufficiently high that you're only drawing in liquid into the pump. As it can sometimes happen, you may have a low tank level. Maybe there's a bad instrument that's not filling it the right way, or maybe there's a leaking valve somewhere along the way that's drawing in atmospheric air on the suction side of the pump. For whatever reason, you may get air into your liquid flow at some point. The degassing valve is an automatic valve that when the air naturally goes to the highest point in the system, which as you can see in this case is the degassing valve, it drops a float down and it allows that air to escape, again, back to the tank. And then once that air is removed because it goes out of the top of it, it's refilled with liquid, it pushes that float back up and closes the valve. So it keeps the system liquid full as opposed to having it with air in it.
I noticed that this one though has it almost looks like some sort of valve or something on the end of it that looks like maybe you could actually manually relieve pressure or something. Why is that pipe, that particular one, have no end? Or does it has an end?
It could be connected to anything that you want. The degassing valve is really just the little blue thing that you see there with the dot next to it. If you go to the left of it a little bit, that's just a valve you could get, a quarter turn valve you can get from anywhere really to drain the system. So it could, if it's water, it can go to the ground.
Okay.
Yeah.
All right.
And the same thing as you see right there underneath the pump. It's the same thing, just a system drain.
Oh, right. Okay. Yeah. Okay. So, okay. Now we're
Mhm.
going into the diaphragm seal and the back pressure valve.
Right, so now that we go to the right, and the first thing we're going to run into is the diaphragm seal, and you see on top of that is a pressure gauge, is what we're showing there. And the reason we're using that is to protect that pressure gauge from what could be hazardous fluids, right? So a diaphragm seal has, it's very similar to a pulsation dampener, that it has a diaphragm in between the process fluid and the pressure gauge in this case. But instead of being filled with air, it's typically filled with glycerin or halogen or some sort of liquid that directly acts on the pressure gauge to allow you to read the pressure without the gauge being exposed to the process fluid. The reason this is important is because in order for the gauge to work, it has to be filled with the fluid that it's reading the pressure from. So if the fluid itself is very hazardous or corrosive, then you have to buy a very expensive gauge to be able to handle that fluid, or you can buy a relatively cheap diaphragm seal that separates those two things and allows you to use a more economical gauge while still reading the pressure of a potentially dangerous fluid.
And then, okay, so then the back pressure valve, we're almost down to the end of the line here. So then there's the back pressure valve.
We're getting there. Yeah, the back pressure valve is very similar to the pressure relief valve, but now it's operating a little bit differently. Metering pumps, for the most part, need to have some sort of pressure to push against to be effective, to be the most effective. And a lot of times we need to maintain a certain amount of pressure on that system for some other components to work. In a simple example is the pulsation dampener needs a little bit of back pressure to be able to work properly. So we can use that back pressure valve that only opens when the pressure on the upstream side of it is at a certain point. So similar to a pressure relief valve, but instead of a safety device where it opens when something is exceeded, it opens when you've reached the point that you want to reach, and it allows fluid to pass through while still maintaining the proper pressure on the back side.
Okay, and then you go down to the diaphragm seal and the injection quill.
The diaphragm seal in this case is the same as when we just talked about. We just have a pressure gauge downstream of the back pressure valve because the pressure is going to be different, right?
Because this is the pressure coming back the other way.
This is the pressure that's passed through the back pressure valve. It's at the system is the proper pressure. We're now allowing fluid to pass through and go into where we actually want to inject it. So just two different pressure readings on either side of that valve.
Oh, I see. Right. Okay.
And then,
and then the injection
and
quill
then we go
is your final.
That's where we actually do the job we've been trying to do all along, right? The whole point of all of this was to inject something into the process flow. So what you're seeing there on the bottom right is the pipe that has the fluid passing through. In this case, we'll say it's just water, right? And we're adding some sort of chemical to it. Well, in order for it to mix properly, we need to add it really to the middle of the fluid flow. The flow of the fluid along the walls is at a lower velocity because it's in contact with the stationary walls of the pipe. The fluid in the middle is at the highest velocity. So we want to inject that fluid where it has the best chance of mixing and being the most effective. So the injection quill is used to go to the middle of the pipe where the flow is the best, and that's where the fluid is injected. And all of these components that we've talked about, the only one that we've talked about that Blacoh doesn't make really is the pressure gauge. But everything else on this metering skid is a Blacoh product. So we're involved in every different component of the metering process.
How do you then go to market? Like, is something like this diagram that we just walked through? Is there an engineering company that has this design and you go plug in, or do they send you something? They say we won't need something designed. Like, what's the stages to getting this put into the system?
So we have all of these things already designed as standard products that fit what the industry needs, right? So there's different sizes of pulsation dampeners and back pressure valves and pressure relief valves and all these different things that are fit for certain metering pump skids. So the metering pumps themselves are the driver of the size of the system, right? The pump can move a certain amount of fluid at a certain amount of pressure. So it's relatively easy to size the rest of the components to fit that application, which is basically the metering pump itself. So in some cases, we'll have a customer come to us and ask for just a single component. And maybe it's because that's the one they know that we make. Maybe it's because that's the only one that they really need for this application. But in other cases, we will be asked to supply all of the different components for the system, and we can do that as well. So it really varies on what the customer needs. And of course, there's plenty of customers out there that are end users as opposed to the metering skid manufacturers that may just be trying to replace something, right? They might have gotten this skid delivered to their plant and it's been in service for a few years and now something needs to be replaced. So they come to us because they see that it's a Blacoh product, and we help them find a good replacement for
So
it.
you can go direct to Blacoh then?
Yes, you can. We have an online store, and we also have our own salespeople that work directly with end users. So we try to be as easy to reach as possible.
One thing I want to, before I let you go, is just sort of the industry outlook. Where do you, the development, is it just things getting bigger, more demand? Where is sort of the focus for that R&D side, product development, that side of the business?
Yeah, that's a great question. If you think about the positive displacement pumping market, there's as always there's development in different directions, right? On the air operated pump side, we're seeing some larger pumps, I would say, but really we're kind of seeing a drift more towards electric pumps and getting away from air operated, working in the same way, the same function on the fluid side, but being driven in a different way. And those pumps still will need to have pulsation dampening. It's still being moved in the same way. It's just being, as I said, driven by an electric motor as opposed to being driven by an air motor. And then on the higher pressure side, we're starting to see higher flows and higher pressures. Blacoh does make high pressure dampeners already, and we're seeing that there's more demand for those and more certifications. People are looking for more backing to say that this is a good product, and Blacoh is offering those as well. One example is ASME certifications for our higher pressure dampeners. That we know that customers are looking for that kind of that backing that says this is looked at by more than just the manufacturer. This is consistent with a industry standard like ASME. And then even going beyond that, we're starting to see more and more on the larger positive displacement pumps, primarily in, I would say, hose pumps or peristaltic pumps, where dampening is becoming more of an issue. As these pumps become larger, there's more need to dampen those pulsations because it's higher flows. As I mentioned before, the higher pressures will cause a greater effect on the piping because you get more variation in the pressures. So that drift towards larger pumps with higher pressures is always the case, right? That's the way industry always moves. We always get bigger and I'll say more difficult to deal with. And because Blacoh really designs products to be able to mitigate that risk and mitigate that effect, we have to follow suit, right? We have to continue with developing products that meet those needs.
So I just wanted to clarify what you said. So because the pumps get bigger, then the pulsation, it becomes a larger gap between the flows, right? As it's rotating.
It can.
Yeah.
Right. And in general, even if the pressures stay the same, as you move more liquid, you need more dampening volume to be able to handle that higher volume, right? If you think about how the dampener works, you're compressing the gas as the fluid comes in. Well, if you have a lot more fluid coming in, you need a lot more gas to dampen that pulsation. So it's a mix of pressure and flow, but in a lot of cases, it's both. Right, that's how things go. We want more flow and we want more pressure.
Just to expand on that a bit, Chris, you've got another diagram. Can you walk us through this a little bit?
Yeah, I'd be glad to. So we talked a little bit before about how the pumps are getting larger, getting more flow and more pressure. And where we really see this happening is in what would be called a hose pump or a peristaltic pump. There's lots of smaller hose pumps or peristaltic pumps that are used in metering applications, 1 inch, 2 inch, those kinds of sizes. But there's also a lot of other pumps that are used in difficult applications that are larger, 3 inch, 4 inch, 5 inch, even in some cases 6 inch pumps. And you can imagine as these pumps get larger, then the pulses that you're seeing, the volume of flow that you're seeing, and in some cases the pressures may be significantly higher. So we've noticed that there's very few products out in the market right now that are applied directly to these higher pressure and larger peristaltic pump applications. So Blacoh is coming out with the SurgeShield product line, which is designed specifically for these applications. And as you can see in the diagram we're showing here, there are a couple of applications on either side of the pump, right? So we have a need for dampening the pulsations on the inlet side as well as on the outlet side of the pump. And the SurgeShield line is designed for both of those. The inlet side of the pump is where we typically see problems with the hose failing. And when a hose fails in a peristaltic pump, it can be a huge undertaking to replace that hose just because the pump itself is so large. So dampening pulsations on the inlet side is very important. As we look at the discharge side of the pump, now we're passing high pressure fluid downstream of the pump that can impact a lot of other components. So dampening on the discharge side of the pump can be very valuable as well. Designing vessels that are specifically made for peristaltic pump applications requires some thought and some understanding of how the system works. And that's what Blacoh has been working on for the last 45 years, is understanding how these systems work and being able to create solutions specifically for those things. The SurgeShield line is going to be a standardized set of vessels that are designed for certain peristaltic pump sizes. And the first ones we're going to come out with are the 10-gallon, the 25-gallon, and the 37-gallon. These are designed for specific pumps. And we also are going to come out with other sizes, 60, 75, 100, and maybe even larger, to fit the needs of peristaltic pump users in the field that are doing jobs that only peristaltic pumps can do. When we look at this diagram, there are a couple of components on here that you might recognize from the metering pump side. And we do offer these things, but in the larger peristaltic pump sizes, our components are a little bit too small. So the back pressure valve and the pressure relief valve are typically more used for the metering pump side. When we get into the larger peristaltic pumps, those are outside of our range. So we can still supply the diaphragm seals, of course. Those are used for pressure gauges, but the back pressure valve and pressure relief valve are typically limited to metering pump applications. We're very excited about the SurgeShield line. We think it's going to have a lot of value to peristaltic pump users, and we feel like it's something that we'll be able to deliver quickly and effectively to anyone that might need one anywhere in the world. That's right.
Yeah, it's, there's, obviously we're just scraping the surface. I hope Blacoh comes on again, but it was good to just walk through. I always encourage people to just get in technicals because that's what people want to hear on the show. So this is perfect. That diagram that you have on your website. What will be what is the focus? Just quickly, what is the focus at an event like WEFTech?
Well, I would say right now it's showing customers what we have to offer outside even of pulsation dampeners. I think Blacoh is pretty well known, honestly, in pulsation dampening. But that's kind of the reason we wanted to walk through this today too, is Blacoh makes a lot of other products that are part of the same system, but are outside of pulsation dampening. But because we understand the systems themselves relatively well, we're able to create or provide these other components at the same time because we've been involved in the pulsation dampening side of metering pumps for so long. And I think that's, if I'm looking around the booth right now, we have a couple of pulsation dampeners, but we have a lot of valves, and we have a few diaphragm seals. You know, the things that we want to show people that Blacoh is more than just pulsation dampening. Even though we're known for that and we're very good at that, there's other things that we can offer as well.
Well, I certainly hope we've helped, at least in a small part, with that part of the message. When walking through that, I'm sure we'll let a few people know anyway. So, Chris, thank you very much for being on the show. I hope we do this again. I would love to get into some of the different setups at different sites that you're supplying and things like that. There'd be so much more we could cover, but this was a good starter. So thank you very much. And I know it's just kicking off, so have a great event as well.
Well, thank you. I appreciate it. And it was great talking with you. Really good questions. And thanks for the time.
Okay. And thank you, everybody, for watching. Of course, we'll have lots of links, as I already said. You could go check out Blacoh. If you're seeing this from like LinkedIn, make sure to follow them. Make sure to follow us. Subscribe to our channel. Go check out Blacoh. And thank you to their team, Jen and Chris, for putting all this together. We will see you on the next episode of The Construction Show.